Hello friends, welcome to Civil 3D Tips and Tricks channel. Today we will learn element method in vertical design. If you want to learn element method in horizontal design, go to the link at the top. So let's start the video. I will show you different conditions and use of different tools for different locations. In first part, we will learn the line methods for fixed tangents. So this is my alignment and this is my profile view. So I will select profile creation tool and I will create editor. So in the line method you are having this much tools, and the first two tools are fixed tangent and the second is fixed tangent best fit. So when you are doing design at any constraints where you want to match the existing levels same as the proposed level at that location, for example, let's say at structure location you want to keep the existing grade same as the existing one. So what you can do is go to the line method and select the fixed tangent. Select the start point of your constraint and end point of your constraint. Click enter. So in this location my grade is 2% for this location and it is fixed, so it is not depend on any other element. So unless and until I change this element, this will change, otherwise it will remain as it is. It will not having any impact on any other element. So this way you can use this fixed tangent. The second is fixed tangent best fit method. So when you want to design a single line, let's say I will take the another example for this. So suppose this is my existing ground and I want to design my propose in such a way that it will follow the existing ground as much as possible. So what I can do is I can select this method and it will give me three options. I can generate it from Cogo points by clicking on the screen. In this option I can define 4-5 points, and based on that it will create one fixed line. And the third is from entities. So for first example I will take this from entity method, and if I will select OK and select any of the entities. So I will select this entity. So you can see it is considering various PI points, and based on that it is creating one fixed line. If I right click it and click it and accept it, it will create one fixed line based on this profile. If I don't want this, I can create based on points as well. So I will use the same option. I can use by clicking on screen, and I can define 4-5 points. Suppose I want this point, this point, this point, and this point. So it will create one average line based on that. I will do it again. I just click the escape key. So first point, second point, third point, fourth point, fifth point, and accept the solution. So it will give you a fixed line. So this way you can use the fixed elements in your design. In this part we will learn the various methods for the fixed curves. So you can see there are two menus. One is for the line objects and the second is for the curvatures. And the curvature menu is subdivided in three parts. One is fixed, second is float, and third is free. So let's start with the fixed objects. So similar to the line, we have the first option of fixed curve. So in this we have to define 3 points. So if you have any constraint, like here our constraint is in straight portion. So suppose if my constraint, let's say structure, is in curvature portion, so I can use this option. So I will select the first point, I will select the midpoint, and I will select the last point. So you can see it is fixed. I will delete the first element so you can If the elements are not joined, so it will not show you the labels. So you can see this is my 3-point curve, and it is matching exactly with this existing curvature. So this is first method. Now in the second one, you have 4-5 types of fixed curves. So if you don't want to remember this, you can always read this text. So the first method is having 2 points and parameters as an input. So in this you have to define 2 points, and then you have to type parameters like what type of curve is that. So that type of parameter is required. So let us see one by one. So I will select the first 2-point and parameter. So it will ask me start point, then end point. Now it will ask me whether you want crest or sec. So let's say I need crest curve of 50k value. So it will create one curve. Now if I want to check that, then I can delete this one. I will delete this element. You can see my k value is 50 here. My curve type is crest, and you can also select it from design editor. You can always check. And this is editable parameter. So if instead of 50, if you want 30, you can change it. So this way you can use this option. The next option will only ask you the entity and the through point. So if I select this option, my first input will be entity with which I want to attach, and the second input is endpoint. So if I give this 2 parameters, it will automatically create one curve. Now the next one is 2 points and grade at a start. So in this one, I have to define the start point, I have to define the end point, and it will ask me a grade at the start point. So if I say, let's say 2%. So you can see my fixed curve has been designed. If I delete this one, you can see that clearly. So you can see my curve has been designed, and if you check the element editor, you can see your grade in is 2%, and grade out based on depend on what endpoint you have given, but this way this will work. If you want to fix this grade out option, then you can select the next option, which is 2 point and grade at the end station. So this way it will work. The next one is parabolic curve. If you want parabolic curve with high and low point inputs, so you can select this one. So it will ask you the location of high point or low point. So suppose I want high point at this location, and this is crest type of curve, and let's say k value is 23 and my curve length is 50 meter. So it will generate one curve with that parameters. If I delete this element, then you can see that element parameters. My k value is 30, length is 50 meter. So this is rarely used, but if you have this constraints like high point and low point, you can use this type of curves as well. And then in the last point, it's similar to this one. So but it instead of parabola, it will be circular curve. So it will ask you the high point, low point location, whether it is a crest or seg. So let's say my radius is 60 meter and my length is say 80 meter. So you can see my curve has been generated with that parameter. So this way you can design, use this parameters. And the last one is fixed vertical curve. So it work in the same way it do in the line method. So select the option and it will give you 3 options. You can do it based on COGO points by clicking on screen and from entities. So let's say I will use entity method and I will select this AutoCAD entity. You can see there is one fixed curve has been drawn based on these points. And just accept the solution. It will create a curve. So this will help you when you want to average out the existing ground. So this is the fix method for the circular curve. In this part, we will see the line methods for float objects. So let me start. So in the line menu, we have three type of float options. So first is the float tangent, second is float tangent through point, and third is float tangent best fit. So let's start with the first one, float tangent. So suppose you are having one fixed curve here. So if I see in the element, my entry grade is 8.89, my outer grade is 0.27. So what I want to do is I want to create one fixed line from the point where my slope is reaching 3%. Let's say for example 3%. So I will select this option, float tangent. This will ask me the entity. So all the float objects need one entity. It is float to some entities, that's why they are called the float objects. So I will select this object and it will ask me the grade. So I will select, let's say 4%, and it will ask me length, so let's say 80 meter. So you can see now if I check this one, you can see my out at point where my grade is 4%. At that point the line has been changed and it is the having length of 80 meter total length. So this way you can use fixed lines. The second option is suppose I don't want any grade criteria, I want particular pass through point. So in that I have to select the entity and I have to select the pass through points. So you can see it will show me the possible solutions, and if the solutions are not available it will show me this red symbol. So let's say my pass through points is here. So if I select that pass through point, this object has been modified based on that. So this way you can use the float objects. And the last method is fix best fit. So if I use this method, it works same as the other part, but what is the difference here? You need one entity to make it float object, and let's say I will select on the screen. So based on my points, it will create one line, and if I accept the solution, it will create one line based on that points. So this way you can use the float objects, and if there is any changes in this one, so this objects are attached to this one. If I do any changes in this one, so I will, let's say I will delete this, and if I will use the first option, I generate 4%. So suppose this is my object, you can see I can increase the length. So whatever parameters I am giving here, that is editable later on. And if suppose I want to change the grade from 4% to 3%, so how can I do that? So go to this, instead of 4% choose 3%. So the design has been modified based on that. So this way you can use the float objects. In this part we will go through the float curves. So it is similar to the line only. So the float objects need one objects before that. So in this case it can be a line or it can be a curve. So I will start with these three options. So in the first option we need parameters and through point. So let's say I want to attach with this entity, and this is already a crest curve, so I will select sag curve. My k value is 22 meter, and for endpoint you can see these are the available solutions, and you can see based on my endpoint the object is floating here. So let's say this solution is acceptable to me, so I will select this and right click. So you can see the object has been changed in this much part, and it is been applied on the parameters which I have given. So this is the first option. Now in the second option, I have to define the through points and grid. So I will continue this one. So my through point is this one, and based on the grade it will modify. So I will say that my grade is 3%. So you can see it has been modified. So this object length has been shortened down to apply 3% grade. So let me change the parameters. It is non-editable, so I will delete this element and let me do it again. So I will say like this is my through point and my grade is 2%. So you can see this has been modified based on this, and this entire length is floating to this object. So if there is any change to this object, the entire object will float based on that. So you can see these two objects, this object is modified based on this and this object is modified based on this. So this way you can use the float objects. And the last is the best fit curve. So I will select the entity and I will select the points. So these are my 3 points. So based on that, the solution has been generated and this is my floating curve. So this way you can use the float curves. In this part, we will learn free curve utilities. So in this one, we are having this much options. So I will start with the free curves. So for free curves, we need two entities. So I will start with the first one. So first one is free parabola curve. The second is free circular curve. So in this two options, we have to select the parameters based on two entities. And in this one, more floating curves, we have different options. In this, we can select our PVI points, point of vertical intersections. So, and in this, we have three sub options. One is we can create parabola curve. The second is we can create circular curve. And third is we can create asymmetrical curve. So I will start with the first one. So in this one, you have to select the first entity and select the second entity. And you have three options. You can either specify radius, you can specify pass-through points, or you can select k value. So let me select k value and I will provide 22. So you can see my curve has been designed. So this is parabola curve. So similar way I can draw a circular curve as well. So I will delete this one and go to this, select circular curve. So select the first, second entity. Now in this you can use either specify radius, length or pass-through point. So let me select range and let me specify range length 60 meter. So you can see total length is 60 meter, and based on that this circular element has been designed. Now in this next one we can define different PVIs. So how this will work is, so let me use the first option for parabola. So I want the point of vertical intersection here. So this is already extended. So I will select this point. And the second parameter is curve length. So let me give 60 meter. So this curve has been designed with that parameter. Similar way you can do it for the circular curve as well. So let me take this as a PVI and my curve length is 90 meter. So this has been modified based on that. So the last option is asymmetric parabola. So how this will work is, I will show you. So suppose you have this type of situation and you want to assign asymmetrical parabola. So this is my PVI point. Now I don't want symmetric curve. Suppose I want 50 meter on this side and 70 meter on this side. So I will specify spiral 1 length 50 meter and spiral 2 length 70 meter. You can see my PVI point will remain here, but my curve is having 50 meter on this side and 70 meter on this side. So this way you can use this type of this options wherever required. And based on element method, you can use this two menus for the element method design. For PVI methods, you can use this methods. So these methods are quick, but wherever you have constraints and you want accuracy, you can use this element methods. And the other tools can use is, this is element editor. So if you want to edit particular element, you can use this option. So once you select, the parameters will be listed here. And this is tabular editor. So wherever you want to do any editing for the entire length, you can use this menu. You can directly change the grade in, grade outs, curve length, start station, end station, etc. So thanks for watching this video, and for more videos you can subscribe to this channel. Thank you very much.